All right, macroevolution. In this case, we're talking about things that take a long period of time. Remember, microevolution, micro means small like microscope, short amount of time. Macro means large. So we're talking about things that take a long period of time. We're talking tens of thousands of years, millions of years to change. Okay, so that's macroevolution. One example of that is the finches. Natural selection selected for finches that had different kinds of beaks that were more suited to the environment. So Darwin is considered the father of evolution, and he made all these observations, and he came up with the theory of evolution, which is not just a theory, as we saw in the previous videos, but we're going to go through some of the evidence in another slide deck. Okay. So macroevolution also addresses how new species arise. Okay, it's not like, oh, all of a sudden there's a brand new species that popped up. Okay, there are some very specific things that happen. So we're going to look at that. A new species arises through a process called speciation. There are a couple different kinds of speciation. Okay, the first one's called allopatric speciation. So the green population here, you can think of it as a green population of whatever kind of organisms. Okay, it doesn't really matter. But all of a sudden, there's a geographic barrier that appears, whether it's due to an earthquake or volcanic eruption or something, and a population gets separated permanently by a physical, this is really important, by a physical divider between them. And over a long period of time, they're geographically isolated, they are unable to interbreed, and they actually turn into, because of mutation and because of natural selection, two different species. So basically the original species, the original population, got separated in half permanently by geographic barrier. They cannot breed on either side of the barrier. So the green guys breed amongst themselves, the blue guys breed amongst themselves, and that's what turned them into two different species. Okay. Another example of speciation is called sympatric speciation. So an example of that would be sexual reproduction or reproductive isolation. So there are organisms that reproduce at different times. So if organisms in the same species start reproducing at different times, they can form their own separate population, if that makes sense. So what happens is, over time, it's not like allopatric, which is a physical barrier. This is a reproductive barrier, or reproductive isolation. So if they reproduce at different times, if flowers flower at different times, it will then cause two different species to arise. That's sympatric speciation. Coevolution occurs when there's a change in one organism and another organism also changes to adapt because it is more fit. So, for example, look at this flower here. Over time, if this flower has changed shape, this bird, the most fit birds are the ones that have evolved to have a curved beak. Okay, so it's called coevolution, like co-pilots, like co-dominants. Both are changing at the same time. Now, as far as the timing of evolution, it's very slow generally when environmental conditions are very stable, and we call that gradualism. Yes, there will be evolution, but it's very slow, very gradual. Okay? However, there are times when the environment is changing, and evolution happens not quickly, but happens more quickly, and we call that punctuated equilibrium, in a burst of change. Okay? An easy way to remember that is punching is quick. It happens in a burst here, a burst there. Okay? So that's the timing of macroevolution.